Let's perform SMS sending and DTMF call operations via the microdiagram program. Firstly, we will use SMS receiver and SMS sender blocks on the screen. We've brought the SMS sender blocks to the screen, which have IN, trigger, NO, and message inputs. SMS sender blocks work with string reference blocks. We took a string reference block to the screen. String reference blocks are where we define the number and message content and work with the string table area in the project section. This area is where we define the string offset. The part where we define the number and message content is the text table area in the project section, which is limited to 64 characters. Let's write the phone number into any string in the text table. For example, for testing, I'm writing my own phone number. Then, in the message content area, I enter area A alarm as the SMS to be sent. In the string reference block, we selected the relevant string offset, the phone number, for the number entry. We also entered the content of the SMS to be sent in the message entry. Let's be careful not to include special characters. Here, the SMS process will be performed to the number we defined according to the trigger information sent to the trigger input. I will provide the trigger information with a binary register block. Now let's talk about the SMS receiver block. Similarly, we have a number and message input section. We place a text reference block in both the number entry and message entry. How will the decoding be done? Will it be compared by string array, by converting ASCII to an integer, or as a text value? I chose string array comparison. Here, we wrote test in capital letters with the help of the string table to the relevant string offset. The SMS receiver block works together with an AND gate. Let's take an AND gate from the logic blocks. We are taking the process by passing the flag and output through the AND gate. The reason is this: the flag output throws a false instantly in every sent SMS. Output gives 1 when the correct SMS is sent. If the wrong SMS comes, if there is a string array comparison cannot be made problem, it will be 0. Therefore, if both are 1 at the same time and throw false instantly, it will pass through the AND gate. We will also take an up-down counter to count the incoming SMS upwardly. We activated online monitoring from the block property table. Let's have completed the device loading process in this way. I established the connection over Ethernet and let's do the tests through online monitoring. We will examine the SMS sending and receiving process with the help of the microterminal. We connected to the device over TCP. We will also examine from the microterminal over the serial port. Firstly, I will send a value to the binary register. That is, when I send a rising edge to the trigger input, as seen on the microterminal, the area A alarm SMS has now come. Again, for SMS to go, a trigger must be applied on the rising edge at the trigger input. By the way, let's give this detail. We dropped the IN entry to 0. If we connect any value to the IN entry, we must write it with the %s format. Now we will test the SMS receiver on the other side. I am sending an SMS named test with the SMS receiver block. Our SMS named test came as text, and because it was the correct SMS, we completed the SMS process by passing Now I will send a wrong SMS. I sent it by writing ABC. Therefore, it did not pass through the AND gate, and it took a trigger once as displayed. Therefore, when I send our correct name again, it passed through the AND gate again. Thus, we have provided 2 triggers with this process. Let's continue. We stop live monitoring. Similarly, I mentioned the IN entry earlier. The working logic of the IN entry is as follows. Suppose we connected a block to the IN entry. For example, we want to transfer the block value of 20 written into the SMS. To transfer this, we need to write %s in the message content section. Let's perform the display in the string table. For example, if I write register value %s, it will transfer the value of the block at the IN entry instead of %s. It will also transmit in this way when sent. Suppose there are multiple analog input data. Instead of using a separate SMS send block for each, I want to display them in one SMS. This is done as follows. Block numbers are seen under each block. 5000, 5001, analog inputs change. The writing style is as follows. For example, AIO equals $5000, AI1 equals $5001. With this writing style, we take the value at the block number 5000. We transfer multiple values with a single SMS using this writing style, block numbers, and the $sign. The processes of sending and receiving SMS were like this. In our next work, we will do examples of DTMF calls, DTMF incoming calls, and originate DTMF calls. We can use the text string reference again in the number entry. Or we have the chance to write the accepted phone number by double-clicking inside the block. As displayed, we can enter the phone number here or use an external string reference block. First, let's make the selection of the phone number. Then, we associated the section where the number to be called is defined with the string reference block. Let's use a binary register block again to start the call. I connect it with the call entry. That is, when a trigger is applied on the rising edge at the call entry, the PLC makes a call to the mobile phone, the defined number. There is silence after the call here. Let's activate online monitoring. Let's display for the test. Again, we will see the commands in the microterminal. First, I will show the call. When I send a command on the rising edge to the binary register, my phone is being called now, the call came, and I ended the call. I made a call to the number. Again, a trigger must be applied on the rising edge for the call to go. Now, in the next step, I am calling the PLC, and let's examine the DFTM call. When we do *6 hashtag, we transferred the value of 6 to the output. When we do *123#, we transferred the value of 123 to the output. Output, you can control multiple relays with the values you enter or control your digital outputs with a DFTM call. The next blocks: string reference block, string manipulation block, and string operation block. What can be done with the string manipulation block? Convert the incoming number to string, concatenate texts, add a value at the end, clear and replace operations can be done. In the string operation block, find, compare string length, and convert text to ASCII number operations can be performed. With the help of text modification and text processing blocks, you can perform operations with incoming texts.